In the last video, I looked at some techniques, basic techniques for factoring polynomials. In this case, we'll look at more advanced techniques. We'll still be looking at the same formulas. So for binomials, here are the formulas that I gave you last time, the last video. Have the difference of squares, factors into the difference of the roots, square roots, and the sum of the square roots. There's your formula for the difference of cubes and the sum of cubes. Notice this, the difference in the signs. Pretty much the same type of formula, except a few changes in sign here. Then I gave you some formulas for perfect square trinomials. And basically, we looked at factoring binomials and trinomials, and we pointed out that always look for a common factor. And if it's a binomial, you look for difference of squares, you look for difference of cubes, or sum of cubes. If it's a trinomial, you look again for a common factor, and then you try to proceed and factor the trinomial using a trial and error method. And then if you have more than 3 terms, we look at a grouping method. So let me just go show you the ones I did last time. You can look at these, and those are the answers that I came up with. And pause the video if you need to look more detailed at these. So in this video here, then we're going to look at again basically the same type of problems, except from a more advanced point of view. So on the next one, or actually the first one for this video, we have this problem right here, and this one has 4 terms. So again, if you have more than 3 terms, you look at a grouping method. Okay, so sometimes it'll be 2 terms and 2 terms. In some cases, it could be 3 terms and 1 term. So you're going to have to play around with it. Okay, and again, keep in mind that we're still going to be using the same techniques from the last video. So in this case, I want you to look at the first 3 terms of this problem here. X squared minus 6x plus 9. You should recognize that as a perfect square trinomial, or you try to factor that out, and it factors into x minus 3. And x minus 3. Okay, so that's a trinomial. The first 3 terms make up a trinomial, x squared minus 6x plus 9, and it factors into x minus 3 and x minus 3, and I'm just going to write that as x minus 3 squared, and then I have minus z squared. Okay, so look at that as 2 terms, difference of 2 terms. The first term is x minus 3, and then it's squared, and then the next one is z, and that's squared. Okay, so it's a difference of 2 squares, difference of squares. So using the formula for difference of squares, that should factor into the difference and the sum of the roots. So in this case, of course, we're looking at square roots. So the square root of x minus 3 squared, we can write that as x minus 3. And of course, the square root of z squared is z. So this then factors into these factors right here. X minus 3 minus z, and x minus 3 plus z. Okay, so it's 4 terms. So basically we group the first 3 terms together. We let the second term the way it is, and we set it up as a difference of squares, and then apply the formula for trinomials, difference of squares. Okay. The next one again has 4 terms. So again, if you have more than 3 terms, you look to group and see if you can find a factor in common. Okay. So sometimes it's going to be mixed up. Okay. So in this particular case, I made it a little bit easier because I'm just going to look at the first 2 terms as a difference of squares and say x squared minus y squared factors into x minus y. And x plus y. Okay, so I factored the first 2 terms together as a difference of squares, x minus y times x plus y. The last 2 terms, px squared minus pxy, I'm going to take out a common factor. Okay, px is common to both of those terms, so I'm going to take out a px. So that's going to leave me in the parentheses here, x minus y. Okay, so now look at that as 2 terms having a common factor of x minus y. Okay, so look at this as 1 term right here. And this is 1 term right here. And they both have a common factor of x minus y. So I take the common factor of x minus y out. And what does that leave me? Well, in the first term, that's going to leave me with x plus y. I put x plus y in that second parenthesis. Okay, so I'm just bringing out the x minus y. So that leaves me with x plus y and of course plus px. Okay, so this one then factors into x minus y and x plus y plus px. Okay, so this is your answer right here. Okay, so we're factoring trinomials, binomials, or in some cases expressions with more than 3 terms. Okay, so let's clear all of this. Go to the next one. Okay, in this one, x cubed plus 2x squared minus 13x. If I try to group these any way possible here, the first 2 terms together, the last 2 terms together, the first 3 terms together, and try to group them to find a common factor, I have no luck with that. Okay, so in this particular case, since I have a polynomial with 1 variable, I'm going to write out, and it's in descending powers, so I got x to the third, 2x squared minus 13x plus 10. I'm going to write out the coefficients of that trinomial. Or actually, it's not a trinomial, it's a polynomial, because it not a trinomial because it has 4 terms. Okay, so let's just say it's a polynomial. And so I'm going to try just to factor it. So I'm going to use some basic theorems from algebra. Again, if you have a polynomial in descending powers and the coefficient of the lead term, in this case x to the third, is a 1 or a minus 1, then the factors, the possible rational factors, or zeros I should say, of this polynomial are factors of the constant term here, 10. So plus or minus 1 could be zeros of this polynomial. Plus or minus 2 could be zeros. Plus or minus 5 could be zeros. Plus or minus 10. Okay? So, in order to find one of these zeros, we just test it out using synthetic division. Okay, so if I put a 1 right here, okay, then bring the 1 down over here, okay, we're going to test out to see if 1 is a 0. So I go 1 times 1 is 1, bring it over here, then we add, this is 3, then 1 times 3 is 3, bring it over to the next column, add these, I get negative 10. 1 times negative 10 is negative 10. Now, since I get a 0 here when I add these, that tells me that 1 is a 0 of the polynomial. But again, using your basic properties or theorems from algebra, if 1 is a 0, then x minus 1 is a factor. Okay? So basically what this is doing right here, when I do this synthetic division right here, what I'm actually doing is I'm dividing this polynomial by x minus 1. So what do I get if I divide the polynomial by x minus 1? Well, I get right here, these numbers in the last row give me the coefficients of the quotient, which is x squared plus 3x minus 10. And by doing this synthetic division, I get one factor that's a quadratic, and I'm able to factor that now. So this polynomial, this x cubed plus 2x squared minus 13x plus 10 factors into this right here. But this right here, it's a quadratic, and that can be factored into x plus 5 and x minus 2. Okay, so this right here then is the complete factorization of this polynomial. Okay, and this is what one of the applications of factoring. If they had given you this polynomial right here, in this case, of course, we're asking you to factor it. This is the answer. But in some problems, they could give you the same sort of thing and they could have asked to find the zeros of the polynomial. Okay. Well, because of this, I could say the zeros are 1, negative 5, and 2, because those are the numbers that make this polynomial equal to 0. Okay. Let's clear this. Go to the next one. Okay, so here again I have a difference of two terms. Okay, so you can treat this as just a binomial, difference of cubes. So using the formula for the difference of cubes, I can say then that if I have a difference of cubes, then the first factor is going to be the difference of the cube roots. Okay, so the cube root of x minus 2 cubed is x minus 2. The cube root of 8 is 2. So this then would be x minus 2 minus 2. Okay. And then the formula tells you that the second factor will be the first root squared. So this will be x minus 2 squared. Okay, then the sign here is plus, and it's the product of the two roots, so that's going to be 2 times x minus 2 plus the square of the second root, which in this case is 2. In this case, we're dealing with cube roots, so this would be 4. Okay. And then you simply have to just simplify this out. Okay, so let's just simplify the first factor. Then it can be written as x minus a minus 2, so that's just x minus 4. Okay. And the second factor, x minus 2 squared, I can write that as x squared minus 4x plus 4. Okay, that's just x minus 2 quantity squared, or x minus 2 times x minus 2. If you do that calculation, this is what you get. And then in the next one, I'm multiplying by 2. That would give me 2x minus 4. And then it's plus 4. Okay, so then I just combine terms there. So I'm going to get x squared, and then the minus 4x and the plus 2x is minus 2x. Okay, and then the minus 4 and the 4 over here cancel. I still got a 4 right there, so this will be plus 4. Okay, so the answer for this one, the complete factorization, then is x minus 4, x squared minus 2x plus 4. Okay. So again, we're still using the same formulas that we used in the last video, involving binomials, difference of cubes, difference of squares, sum of cubes, or you're dealing with trinomials, or in some of these, of course, we're dealing with factoring expressions with more than 3 terms. There's a grouping technique like the ones we did so far. Okay, so let's clear this. Okay. And then the next one has 6 terms. But notice, again, you play around with it, and you want to find some grouping method. Okay, find a technique where you can group them in 2s or 3s or a combination, like the ones I've done so far. In this case, again, I kind of made it easy because it's a first video on these techniques, but keep in mind that they could have it mixed up for you more and make it more difficult. But in this particular case, I look at the first 3 terms together, and that's x squared plus 2xy plus y squared, and you should see, based on the formulas we've had for trinomials, that factors into x plus y and x plus y, or x plus y squared. Okay. The last 3 terms, I'm going to factor out a minus. That would be a squared plus 2 ab plus b squared. Okay. But look at that trinomial in the parentheses, and that's again, you can factor that out. And if you factor it out, it's going to be a plus b times a plus b, or a plus b squared. Okay, so again, look at that as a difference of 2 terms, and since you have the square, it's difference of squares. So this factors in into the difference in the sum of the square roots. The square root of x plus y squared is x plus y. So I'm going to say, okay, it's x plus y. The square root of a plus b squared is a plus b. Okay. So it's the difference in the sum of the square root. So you can put a minus here or a plus. Doesn't matter what order you do this. I'm just going to do this is a plus. And the second factor will be the same thing, except it'll be a minus. Minus the a plus b. So I either put that in parentheses or distribute the minus, so I can write that as minus a minus b. So your complete factorization then, there is x plus y plus a plus b, and x plus y minus a minus b. Again, the order in which you have these doesn't matter, as long as you have the same terms inside the parentheses. Okay, so I'll give you some ideas as to factoring more advanced problems, or polynomials, or forms of polynomials. Clear this? So keep working on these. You have any questions on these, please post them. Any suggestions, again, let me know. And if these are helping you, I appreciate if you subscribe to the channel. And take care. We'll see you in the next video.